Hello, class. I'm creating a video to answer a few of your homework problems. The first question says, what is the APY for money invested at each rate? So if I pull out my formula sheet, I have two formulas for APY, annual percentage yield. The first formula you'll use when you're going to compound monthly or weekly or daily or semi-annually, right? And M would be the number of compounding periods. Where if we're going to compound continuously, anytime you see the word continuously, we use the formula with the E in it, right? Notice it says continuous, there's an E here. This one that you'd use for continuous compounding. So let's work this out. Let's see if I can use this whiteboard here. The first one says 9% compounded quarterly. So I'm going to type the 1 plus my R is going to be the 9% written as a decimal. So 9% as a decimal is 0.09. The number of compounding periods are 4 because it's compounded quarterly. Okay. And I think that's it. Let's see. So what we need to do is put this into our calculator. Again, the R is 9% written as a decimal, right? We were given 9%, 0.09. The M is the number of compounding periods. So we're compounding quarterly. There's 4 quarters in a year, so I put a 4 here. If I was compounding monthly, I'd put a 12 in for M. If I was compounding weekly, I'd put in the 52 for M. But we said quarterly, so there's 4 quarters in a year, so we put in the 4. We pull out our calculator, and I'm going to type it exactly as you see it. Parentheses 1 plus 0.09 divided by 4, close parentheses, and then I'm going to raise this to the 4. And you know what? I forgot this -1, right? So I have to press the right arrow and do -1. And then I press enter. Right? So I get 0.093. So I just want to show you, when I was writing out this formula here, I actually skipped this -1, right? So I have to add that here, right? -1. All right, so let's put back my calculator just so you can see it one more time. I typed everything in here into my calculator, and that makes sense, right? If we're getting 9%, compounded quarterly, your interest earns interest on your interest, right? So you would expect a number that's a little bit bigger than 9%. And in this case, if we move the decimal 2 places, we get 9.3. And it says round 3 decimal places, so it'll be 9.308. 9.308. Just double check that that's what it was. 308. Yep. So let's check our answer. We get the nice work. Next problem, similar. Let's pull out our whiteboard again. So now we're going to use the bottom formula because it says continuously. Okay, so what is that going to look like? I'll just kind of drag this down here. So it's going to be e to the r. In this case, r is 0.11 because it was 11%, minus the 1. All right, that's not too bad. Let's put that into our calculator. I go second. I use the division sign because E is above the division key. There's my E. Raised to 0.11. And I got to put the right arrow to make sure I bring my -1 down here. You don't want -1 on the same line as the 0.11. And we had 11.628 when we round. 11.628. I check answer, and we get the fantastic next question. Next question, a newborn receives a $10,000 gift toward college. How much will the $10,000 be worth in 17 years if you're getting 6.75% compounded quarterly? Okay, so here's my compound interest formulas. So I'm going to use the bottom one. I'm going to use this formula here. So let me pull out my whiteboard again. Whoops. And let's see if I can get some room here. Here we go, compound interest. And it was 17 years, Let's just see if I can put this in a good spot. Okay, so now we can see everything. Let's write this out. So I'm going to use this bottom formula where my A is going to be equal to, let's see here. And, oops, my pen stopped working for a minute. My P is what I start with. So in this case, I start with the 10,000. 1 plus, my interest rate is 6.5%. So we have to change that to a decimal, right? Once, twice, that's 0.065. And the number of compounding periods is 4 because it's compounded quarterly. And the number of years was 17. So I'm going to put that into my calculator and see what we get. I'll type it just the way you see it. So it looks like this, right? 10,000 times 1 plus 0.065 divided by 4 raised to the 4 times 17. Again, why 4? Because it's compounding quarterly, and there's 4 quarters in a year. All right. The 0.065 is 6.5% written as a decimal. The 10,000 is what I start with. So I'm going to press enter. And it looks like I'm going to have $29,925 and some change. So, you know, you almost tripled your money, right? Your 10,000 is almost 30,000. It's pretty good. All right, so let me just write that down. And we have to round to the nearest cent or the nearest penny. So it was $29,925.26. And then just to show you my calculator one more time, I press check answer. Fantastic. And number 20. It says, how long will it take to double your money? All right, now this is a little different. Right, so let's take a look at the formulas we're going to use. Okay, so the thing is, we know what we're going to have in the future. What we're going to have in the future is double, right? So how long will it take to double money if invested at 5% compounded continuously? So continuously means we have to use this bottom formula for compound interest. Now, it doesn't say how much is invested, it just says how long will it take to double your money. So we can use any values we want. We could say my P is $1. Oops, my ink is a little thick there. Let's try that. All right, so my P, let's pretend my P is $1. So double $1 would be $2, right? If I invest $1 now, I'll have $2 later, right? The thing that we don't know is the time. I'll use the letter X for time. Oof, that's pretty sloppy. Let's see if I can write that a little neater. I'm writing on a stylus that's it's a little rough. So again, my R was 0.05 times X, right? Because the time is what we don't know, right? The question says how long. So I have to solve for X. So now let's solve this problem. We can solve this using logarithms or the natural log. So if I have 2 equals, well, 1 times e is going to be 1, e to the 0.05x, step 1, I could take the natural log of both sides of the equal sign to get something that looks like this. And then step 2, I can use properties of natural log, which I can take the exponent and put it in front. So I end up with something like this, 0.05x times the ln of e. And to finish the problem, well, ln e is the same as 1. So this is really like saying ln2 equals 0.05x times 1, right? And I can prove that to you. If I go to my calculator and I press the ln and the e, and I press enter, I get 1. That's just the one property that you probably want to have memorized. So to finish my problem, I'm left with ln2 divided by 0.05 equals x, right? Because I'm going to divide both sides by 0.05 to get x by itself. Right? This is like x times 1, which is the same as x. So when I put this into my calculator, I'm going to do the natural log of 2 divided by 0.05. I press enter. I get 13.8 and change. So let's put that, and it says round to 1 decimal place. So let's do 13.9. And I press enter. So what did we actually do there? Right? We solved for the t here, which is time. So it takes 13.9 years to double your money if you're invested at 5% compounded continuously. Okay? And now for the second part, it's the same problem, except you would just change the 0.05 to 0.07, right? Because it's 7%. That's it. I hope this helps. Thank you for watching.